So now that we have looked at the theory part of the matrix plot, let us move on to the next aspect, that is the code implementation. So just like any other coding video, the first thing which we do is import all the libraries involved. So in this case, we're going to use two libraries, the pandas library and the cborn library. So the sole purpose of the pandas library is to import our dataset, which we're doing now by mounting the Google Drive as well, as shown in the previous videos. So here's a brief look at the dataset. Now if you'll see, and if you have been following the videos previously in our series, you'll notice that this dataset is not new and has been used before as well. So let us look at the columns of the dataset. Now as you guys see, the serial number column is also present and it is not really relevant to our machine learning model. So we are going to go ahead and drop that column. So yeah, the column has been dropped and we can verify that by printing the columns of the dataset again. So if you'll notice, the serial number column is not present here. So now that we have imported our data set successfully and also fixed it by dropping the serial number column, we can actually go and start plotting graphs in our data set. So before we move on to the plotting part, the first thing which I would like to discuss is the correlation matrix. Now a correlation matrix essentially represents the correlation factor of each feature with another feature present in our data set. We have it as follows. So if you'll notice, there's a correlation factor of every feature with another feature. For example, GRE score and TOEFL score have a correlation factor of 0.82, which means they're highly correlated with each other. So what we should infer out of this correlation matrix is we should look at the output factor basically. So in this case, our output is going to be the chance of admit. So we should look at the correlation factor in the chance of admit column. So anything which has a correlation, which has a high correlation with chance of admit, should be included in our data in our machine learning model. So if you'll notice, GRE score has a high correlation of 0.81 with chance of admit, whereas if you notice SOP, SOP has a correlation of 0.68 with chance of admit. So anything that essentially has a correlation of above 0.8 can be a part of the machine learning model which we implement. So the next part after correlation matrix is the heat map. So heat map has been discussed before and it has videos dedicated to it. And you can look at those videos specifically if you want more details on heat map by simply checking them out in our series. They have been uploaded before. So a heat map and a correlation matrix represent the same thing, but a heat map is more aesthetically pleasing and easier to look at. So the data involved in a heat map and a correlation matrix is one and the same. As you can see here, the GRE score and GRE score again have one correlation factor, and the example which we discussed was TOEFL score and GRE score has 0.83 correlation factor. So there are certain parameters in the heat map plot here. We are using the cborn library for plotting the heat map in this video. So the first thing which we pass is the data set, which we're plotting the heat map on. Next thing is the annotation. So what annotation does is it prints the value of the correlation factor in the individual squares. As you can see here, 0.83, 0.64, all these values are printed because of annotation being true. Next is the color map, which is CMAP, which is being set to the plasma value. Next is line color, which is set to black, and line width, which is set to 1. Line color basically represents the color of the line which separates two individual squares. So a heat map and a correlation matrix share the same data, but a heat map is easier to look at and conclusions can be drawn easily as compared to a correlation matrix. So the next type of matrix plot is the scatter plot. So scatter plot again has been discussed previously and it has a theory video as well as a coding video dedicated solely to it. So let us plot a pair plot right here. So pair plot is essentially an array of basically a matrix of all scatter plots, and it will take a while to plot a pair plot because we have around 7 or 8 features. So and another output class, so that makes a total of 9 basic plots. So a pair plot will have 9 into 9 different plots, and each feature is represented with another feature. So all possible combinations of features are represented basically in a pair plot, representing the values of the correlation, which can be derived based on the scatter plot, which we see here. So I'll just reiterate that the scatter plot has been covered before. Sorry, the pair plot has been covered before, and you can simply go on to our previous videos and simply look at the scatter plot. Thank you. That's going to be it for the matrix as far as the matrix plot theory go. Please stay tuned for more videos in the series.